This chapter is different from prior chapters in that we aren't testing hypotheses that will speculate about differences between populations. It is also dissimilar from our regression chapter in that we're not attempting to produce predictive equations with the intention of estimating unknown values based on past observations or trying to predict one's behavior. The statistical technique discussed in this chapter presents a method whereby we, as researchers, can reduce the number of variables we study for a survey instrument. And the subject of this chapter, factor analysis, is a data reduction procedure. And it sounds pretty easy, but we are going to talk a little bit about the two types of factor analysis. We have a descriptive factor analysis that's usually referred to as exploratory. So it's exploratory factor analysis. And then we have confirmatory. And we consider only the descriptive or the exploratory factor analysis in this chapter. There are several other types of exploratory factor analysis, confirmatory factor analysis, structural equation modeling, but that is not covered in this section of the textbook. Your most common exploratory factor analysis is known as principal components. This is an approach that we will use, and when we use principal components factor analysis, the term components is often substituted for factor. And if you require the testing of theories concerning the latent or hidden structure underlying variables, then I recommend that you do a confirmatory factor analysis and use a more advanced text. And in this chapter, we're going to explore for and identify latent variables, but we're not just going to attempt to confirm or deny any hypotheses concerning the reality of their existence. We're just trying to look at an instrument, specifically constructs in a survey, and we're seeing if we can reduce the number of variables used to measure that construct. By the end of this lesson, you'll understand a few more of the factor analytic methods we just discussed. You'll understand when to use principal component factor analysis. You'll know the types of variables you can use. You'll understand how to identify the correct number of factors to pick. We'll rotate those factors for maximum solution. I'll interpret the SPSS output or the results, and then show why it's important that we use this process in survey research. For this lesson, I am going to use one particular scenario from 2010 in which I was a part of a study that was an 8-year producer-led project that uses on-farm demonstrations to determine the production practices that would sustain the life of the Ogallala Aquifer. And the community coordinator used leadership styles to initiate change within individual farming operations and attitudes one might have toward agriculture and water management. Trust is necessary in the information dissemination process and for individuals to influence the behaviors of others. So this study determined which trust factors were most important to agricultural stakeholders when receiving information from the Texas Alliance for Water Conservation. The researchers developed an instrument with items that measured the respondents' level of agreement of importance on 38 trust-related factors or behaviors. Then 55 attendees at the Texas Agricultural Water Alliance Conference Field Day in 2008 completed this questionnaire, and a principal component analysis with an oblique rotation was able to indicate that just 11 of the behaviors were important to stakeholders, and they loaded into one of 3 factors, either relationship maturity, individual customer focus, or transparent and honest. Let's dive a little bit more into the concepts behind factor analysis. The first thing you need to know is that it is a data reduction process where you're taking many variables that are referred to frequently as factors or components and trying to explain them with as few as possible. And we correlate the variables, and those correlated variables are grouped together and then they're separated from other variables with low or no correlation. So you're basically dividing variables into components. And these variables are not classified now as either independent or dependent, but that we're looking for an entire set of interdependent relationships among these variables. And it's examined to define a set of common dimensions that we refer to as factors. The purpose of using factor analysis is to just identify a smaller, new set of uncorrelated or correlated dimensions that replace the original set of your correlated variables. And we typically use this in applied research like agricultural communications, extension education, or agricultural education when we're doing a psychometric evaluation of a multiple item testing instrument, such as a survey. But we can also use factor analysis to validate a construct in our instrument and to reduce the data that we're collecting from a pilot test to the actual administration of that instrument. Our textbook shows a general process for how to conduct a factor analysis and the principal components analysis, starting off with the idea of sample size. And it's really important to understand while he says it's greater than 300, it really does truly depend on the number of factors you have. And there's kind of a general idea of either between 10 and 15 cases, that means individual responses, per factor that you have. And as long as you go through and look at your KMO test and you see that the score is acceptable, then you're not going to really have to worry about sample size. But we are going to do some initial checks, and then we're going to do a main analysis and a post analysis and walk you through the processes of how we can use factor analysis. Now, the very first thing you're going to want to do is screen your data. We don't have the same kind of assumptions that you'll see with regression, ANCOVAs, ANOVAs, and t-tests, but we do need to just look for univariate outliers, multivariate outliers, look for normality, skewness, and kurtosis in our data set. So you'll just do a simple explore data function, look at all the variables you're considering in your survey under those constructs, and then look at them to see if there's any outliers or normality. And I'll now show an example of what this data looks like from our research scenario.